Lesson 9.2 is graphing the parabolas, but now they're in the form y equals ax squared plus the middle term bx plus c. Whereas when you had lesson 9.1, we did not have that middle term. It was just y equals ax squared plus c. And recall that c was the y-intercept. We can use these properties below to graph any quadratic function. And then this is actually going to use this, you're going to justify the formula for the axis of symmetry if we end up doing lesson 9.2 problem 38. Alright, so here we go. The graph of y equals ax squared plus bx plus c is a parabola that opens up if a is greater than 0. So if this first coefficient is greater than 0, then it's going to open up. And it's going to open down if the a is less than 0. So if a is positive, the parabola will open up. If a is negative, then the parabola is going to open down. This is going to be narrower. It's narrower than the graph of y equals x squared if the absolute value of a is greater than 1. So if this is a negative 5, it's still going to be narrower. We say that this is a vertical stretch. So let's go ahead and write that right in there. So narrower means that we have a vertical stretch. And that is if the absolute value of a is greater than 1. And it's going to be wider if the absolute value of a is less than 1. So really we're looking at the fractions here. And remember we said wider meant that it was going to be a vertical shrink. So make sure you put that language in there, please. The axis of symmetry. The axis of symmetry is the invisible line that cuts the parabola seemingly in half. If you fold it over that axis of symmetry, then it would be a perfect copy. So there is a formula for the axis of symmetry, and that formula is y equals, it looks like negative b over 2a, but really this means the opposite of b over 2a. So again, I think that we should write that in there. Why don't we write that over here? Negative b over 2a, that means the opposite. So if b is negative, you make it positive. If it's positive, you make it negative. And then the vertex, this maximum or minimum point here, if it opens up, then it has a minimum point. The x coordinate of that is actually the same as the axis of symmetry. So the x coordinate is the opposite of b over 2a. And then to find the y, you would plug the x value into your equation and then get the y. And then the y-intercept, lastly on here, is the c. And so it's going to have the point 0, c. So the y-intercept is 0, c, or c for this. Alright, so we are going to go ahead and analyze some of these parabolas and we're going to graph them. So first it's asking us to find the axis of symmetry and the vertex of each of these two functions. What I want you to do is identify a, b, and c first. So the a value is 1, the b value is negative 2, and the c value is negative 3. I know my formula for the vertex, or I'm sorry, axis of symmetry, is the opposite of b over 2a. So now it's just a matter of plugging them in. So x equals the opposite of b, which would be 2, over 2 times a, 2 times 1. 2 over 2 is 1. So I know that my axis of symmetry, x equals 1. Now my vertex, I know it's going to be 1, comma, I have to figure it out. So I'm going to go ahead and put this into the formula, y equals 1 squared minus 2 times 1 minus 3. So y equals 1 minus 2 minus 3, which gives me a negative 4. So my vertex is 1, negative 4. And I will use this information later. Well, when we get down here, I'll use this information to make a graph. Let's go ahead and do this next one. A is negative 5, B is 2, and C is negative 3. So I have x equals the opposite of 2 over 2 times negative 5. So x equals Negative over negative is a positive, so it's going to be positive 2/10, which is really 1/5. So there's my axis of symmetry, and now my vertex is 1/5, comma, so I'll plug it in. Y equals negative 5 times 1/5 squared plus 2 times 1/5 minus 3. You can use your calculator if you want. Remember, I taught you how to use the ABC button, so I'm going to go ahead and do that right now. And when I did that, I got negative 2 2/5. So my vertex is 1/5, negative 2, and 2/5. All right, now I'm going to go ahead and graph one of these functions. When you graph it, you need the axis of symmetry, you need the vertex, and then we're going to make a table with values surrounding the vertex because all parabolas are symmetric. So when I graph this, first thing I'm going to do is find my axis of symmetry. So A is negative 2, B is 2, and C is 1. So the opposite of B is negative 2 over 2 times A. So I get 2 over 4, which is 1/2. So my x is 1/2, my axis of symmetry. My vertex is 1/2, comma, and now I'll plug it in. So y equals negative 2 times 1/2 squared plus 2 times 1/2 plus 1. So y equals negative 2 times 1/4 plus 1 plus 1. So it looks like y equals negative 1/2 plus 2. So y would equal 1.5. When I go to graph this, before I make my table, I'm going to go ahead and plot this point. So I have the vertex is 1/2, 1.5, so right here. My axis of symmetry, I'm going to go ahead and just change my color here. And I'm going to change it so that I've got a line. And I do want this to be a dotted line when you graph these, or a dashed line, because the axis of symmetry is a vertical line, but really it's invisible. So we're going to show that it's invisible by making it dotted or dashed. Now I need to make a table. And what I'm going to do is I'm just going to surround it. So I'm going to surround it on both sides of my axis of symmetry. I do know that this is going to open down, and this is my maximum. So I'm going to go ahead and use the point negative 1 and 0 and 1 and 2, and I'm just going to see what happens. I know at 0 my y-intercept is 1, so I have that right here. And then it should be also 1 at positive 1 because they are equidistant away from the vertex. So it should work out just like that. And then if I try negative 1, I'll put a negative 1 in here. And again, you can just use your calculator for this. So I'm going to do this off screen, and I'm going to substitute a negative 1 right in here for these x values, and I'll be back in just a second. With a negative 1, I got a negative 3, so I'll come down here. And now technically that's 1.5 away from the vertex, so if I go 1.5 away, that should give me the same answer right here. It's equidistant. And I'm going to say that that's enough to get me a pretty good looking parabola. So there's the graph of that one. Let's try one more of these. So again, A equals 7, B equals negative 14, and C equals 6. So my axis of symmetry, the opposite of negative 14 is 14 over 2 times A. This gives me 1. So my vertex is 1, comma. When I plug in a 1 here, that gives me 7 minus 14 plus 6. So 7 minus 14 is negative 7. Negative 7 plus 6 equals negative 1. So my vertex is 1, negative 1. I know this opens up because it's positive, and my invisible axis of symmetry is right here. And so when I make my table, I'm just going to surround it. I know I'm going to use 0 because that's an easy one to use. That is the y-intercept, and that is 6. And then I just go the same distance around it, and that's also going to give me a 6. So really, I guess I didn't need a table for this one. I only technically need the 3 points. I like to get more than 3 if I can, but here I would run out of room. So very carefully try to make it look like a U shape, sort of. There's the graph of that parabola. All right, lastly, problem 30. A lighting company offers 2 models of small lamps, both of which contain a reflector in the shape of a parabola. So we've got this right here, our parabola. The shape of the reflector in lamp A can be modeled by this function, y equals negative 1600 x squared plus 25, and the shape of the reflector in lamp B can be modeled by this function. X and y are measured in millimeters. Find the maximum value of each function, which gives the height of the reflector. So really we have to find the axis of symmetry, and then we're looking at the y value of the vertex. So we'll do lamp A here, and for that one the A value is negative 0.16, and there is no B value, so C is 25. So I get x equals the opposite of B, which there is no opposite of 0, over 2 times A. So the vertex here is just, or I'm sorry, the axis of symmetry is 0. So when I plug in the 0, my vertex is going to be 0, that's not a Q, it's a 0, comma 25. Now if I do lamp B, I have the same sort of thing. My A is negative 2/10 and my B, or I'm sorry, my C is 20. So, I can just go x equals, again it's 0, divided by 2 times negative 2/10, which still gives me a 0. So my vertex is going to be 0, 20. Find the maximum value of each function. So A, the maximum is 25 millimeters, and lamp B, the maximum is 20 millimeters. How much taller is the reflector in lamp A than B? Well, you just subtract, and you get 5 millimeters taller. And that is it for lesson 9.2 notes. As far as your assignment, I am going to give you the worksheet that comes with the book. I will go ahead and let you print it off if you would like to start it, if you're getting this at home, or I will have them printed off in class if you think that you might want to grab one.